Hello, my name is Demir Durmazlar. I am an industrial engineering student at Bilkent University, and this is my Physics Lab 101 project. My aim was to investigate how changing the hanging mass and the radius of motion affects centripetal force and the linear velocity. In theory, the tension in the string is equal to both the weight of the hanging mass and the centripetal force. So, solving for v squared in this equation shows that v squared should vary linearly with r, and that it is directly proportional. Um, in my setup, I used the top mass, I attached it to the spring, and in the other end of the string I had my hanging mass. For my top mass I used 20 grams, and for my hanging mass I used 40 grams and then 80 grams for the second part. I attached the string to a tube, a plastic tube, and then I marked my radius values on the string. And then I held the tube vertically and spun the tube so that the rotating mass would be in a horizontal motion and the hanging mass would be stationary. And I recorded the time for 10 revolutions, and I computed the period by dividing the time for 10 revolutions by 10, and then I computed the velocity through the formula 2 pi r over t, and then I plotted the graphs for v square and r, and I plotted the graphs for fc and ft as well. Through my findings, both the v square and r graphs were linear, and they were pretty aligned with theory. The 80 gram mass gave a smaller error of around 7%, and the 40 gram mass gave an error of around 12%, because in the 80 gram mass the tension was higher and it caused the string to be more stable. So the error was aligned with theory as well, and both the graphs were linear, which was expected as well. In the FC and FT graph, my found experimental values were under the ideal line. The ideal line is the FC equals FT line. They were under the ideal line, which shows that some tension is lost to friction and small radius changes. In my experiment, my main errors were due to friction in the tube and radius fluctuation at low tension, and human reaction time when measuring the 10 revolutions. Overall, in conclusion, the experiment confirmed the proportionality of v square and r, and the higher hanging mass produced more stable motion and lower error. Results overall matched the theory. Thank you for watching.